This instructional video is designed to show you how to use information about isotope ratios and relative abundances to determine the atomic mass. In this case, we have lead with 3 listed isotopes. And again, these values are not exact. They're made up specifically for the purpose of these instructional examples. And so in this particular example, we list lead 208 as being twice as abundant as lead 207. And lead 204 is 14% of the mix, and we want to find the weighted average for our atomic mass here. So, what do we know? We know our first abundance is 14%. Our next abundance, will let that be lead 207? Well, that's some percentage. And we know that the abundance for lead 208 has to be twice this, so we have that there. Now, the sum of the abundances of all 3 isotopes has to be 100% to account for everything. And that means then that we can actually determine a value for A. We'll subtract 14 from both sides and combine these two. So we have 3 times that percentage being equal to 86%. Once we know that, it's straightforward to divide by 3 and on both sides. And so we find that that mystery percent is 28.7, rounding off from the 0.6666666. So, this gives us our abundances. For lead 204, we were told 14%. For lead 207, we calculated 28.7%. And for lead 208, this has to be the remainder, 57.3%. So now that we have our relative abundances, we can take the masses and multiply that by the percentages to get our total. So 204 was 14%. We're going to add to that 207, which is 28.7%. And for 208, 57.3%. So we step through this. 14% here gives me 28.56. 28.7% here gives me 59.409. And 57.3% here gives me 119.184. So when we add up the contributions to the overall, we get 207.153 atomic mass units as our solution. And so this is how you can determine a weighted average for your atomic weight, given enough information to determine the individual relative abundances of all of your isotopes.